And so the buzzword came out as, hey, they're going to Burlington, Vermont. 26 of us flew up in a DC-3 on Sunday morning, the 24th of February. And we got rental cars and went to the Hotel Vermont, which was down on the corner of Main and St. Paul Street. Next morning we got up, had breakfast there, and you could tell you were in the ski country because most of the people in the cafeteria either had crutches and leg wraps or their arms in slings. The plant would open up at 8:30 in the morning, but he said, we will be there at 7:30. And thank goodness we came at 7:30 because it was one of those typical February Vermont days, cold, windy, had 100 people in line. And we went to the back line, in front of the line, so on, found out someone were there at 4:30 in the morning. We thought they would just pick up applications and come back later. No way, they said, we waited since 4:30. We're not leaving this site. We're staying here in line so we don't lose our place. And that's what I remember about coming to Essex Junction and IBM Burlington. Setting this place up was extremely interesting. As you know, Building 962 was 40,000 square feet. And 32,000 square feet of that was on the first floor, and the other 8 or so was on the second floor. Second floor was purchasing and personnel. In Building 962 initially, under the second floor, we had, quote, a cafeteria, a place we could sit down and eat. And what happened in the early days that we were here, we'd either had to bring our lunch or order box lunches from Howard Johnson's over on Williston Road, or go to one of the Lincoln Inns, a local inn in town. And in about March or April timeframe, Larry Gerlach brought up his skill in culinary work and his equipment from Poughkeepsie. So he started to open up a little cafeteria, and we no longer had to leave the site.
There had been 6 employees hired before me on March 18th. That was the first hire group. And we were 7 in my group of the next week, March 25th. It was kind of scary because none of us who had been hired had, I don't believe, had ever worked in a manufacturing environment. And of course, we didn't work here right away. We were immediately sent off to Poughkeepsie for training. Well, first of all, the wire contact relays, which was simply an on-off switch, if you want to get that simple about it. And it was controlled through a coil. It was either turned on or turned off. And everyone was a friend. You competed a lot in production. And some people produced more than others, and they would save some of their production out so that they didn't accommodate it that day. So the next day they might be able to coast and then push it through. What happened frequently is someone would steal that product and claim it as their own. Women always tried to outdo the men. The women were almost always better at assembling something, and the men, of course, normally ended up testing it or adjusting it, and that's how the production worked in those days. So it was a fun kind of an environment, really. It got very warm in the summer. A lot of perspiration going on, although there were fans blowing. We did have problems with tolerating the heat simply because it was a metal building and it got really roasting hot. Didn't seem to affect the product too much. For the employees, we drank a lot of water at the water fountain and had salt tablets there to help us along. The only competition we had was always with East Fishkill. And we could do something better than they could. We could do it more quickly, and we could do it more cheaply. But yet we still got along well, and if it started here and migrated there, they could improve on it, and vice versa for us.
It was amazing, particularly since not many of us had been able to study anything about technology in our college careers. So we were all learning together, and we were very fortunate at the time to have 4 or 5 people whom I always considered icons of this site. Vladimir Chernyshov, Rudy Leah, Nick D'Onofrio, Jim Pizziano. Those people were the leaders of this site, and they were the mentors and frankly the teachers for most of us. And most of us ended up being assigned to them during some part of our career, and frankly learned the technology business from them and learned it together also.
I've heard the same rumor that the Watsons liked this area. They had a place out at Spruce Peak, and the only thing that would confirm that, 2 stories quickly that would confirm that would be, number 1, when he came up to visit one time, he brought his mother up. and she was an elderly lady, and they called to see if we had some people at the site who would help her with her baggage. And it was interesting that the plant manager selected 5 functional managers, top of the line, to help her carry up the luggage. So that was one indication. The second one was as I told you, we flew up, and our pilot, who was an IBMer, Chuck McKinnon, his son came to work up here. And one day his son walked into his manager's office in production control and said, "I've got to leave because I've got to go to the airport and I've got to put snow tires on Mr. Watson's car." I remember the time that Mr. Watson was coming up here to visit the site. And he'd gone down to the lobby. Mr. Kilcrease, the first plant manager, had gone down to the lobby because they said Mr. Watson's on his way. So Mr. Kilcrease was staying in the lobby, pacing back and forth. Lucy Marston, who's Lucy Billups in those days, Lucy Marston today, who said, she was the receptionist, she said, "Well, he's coming. He's supposed to be coming, Mr. Kilcrease." And all of a sudden the phone rings. Lucy picks it up and said, "Oh, he's here? Where is he? Oh, boiler room. 962, you had 2 doors. One was the main door, one was the boiler room. If you were a stranger, you didn't necessarily know which was which. Mr. Watson came in the boiler room door, and here he is trying to climb through the boiler room door over the pipes. Here's the general manager waiting for him in the front lobby. So, okay, I'm coming." He races in building 962, if you know where the main door is, through underneath the second floor in the cafeteria and into the boiler room. And here he says, "Here, let me help you through." And here's the general manager of the site holding the president of the corporation's hand as he weaves through in and out of the pipes. That I think is amazing.
I joined IBM as an industrial engineer. Interestingly enough, industrial engineering was located at the Duval House up on Maple Street here in Essex Junction, right where the softball fields are. And because there was only one restroom in the house, only men were allowed in the building, and to work there, that is. And so at that time, very few of the men knew how to type. I happened to have just gotten out of school, and I could do one step better than Hunt and Peck kind of typing. And so I ended up being the typer for all the rest of the guys there.
In terms of core memories, there was several generations, of course. We kept making them smaller and faster and less expensive. But we had gotten to the point that they were so small that you couldn't manufacture them anymore. And the transistors that were required to drive those were impossible requirements. So that technology was plateauing. And if we didn't come up with new technology, Eric Bloch knew that IBM's future was limited. The thing that drove the IBM revenue, the thing that enabled those computers to drive the revenue was memory. And Burlington was the action. You know, we did it. We were the force function for the IBM growth. So we had a group here in Burlington who had the responsibility of telling us what was the competitive target that we had to meet. Ed Berger was the manager of that group. And he told us in 1985, when we were putting the spring plan together, that Hitachi was going to be building megabit chips in 1989 at 0.5 millisecond per bit. So that became our target. I had to put together a plan that did that. Now, we were on 5-inch wafers here. And that's why that plan just didn't come together. So then we realized that if we could do 8-inch wafers, we could get the volumes and the costs. Putting in the first 8-inch line to do 1 micron, 1 meg DRAMs, nobody else in the world had done that. Our 8-inch line was ahead of the Japanese by 5 years. And the reason we were able to do it is because, lots of reasons, but one of the main reasons is the Burlington people, the Vermonters. They've got a fantastic way of can-do attitude, and lots of skills, and really, you know, that was one of the magic ingredients that we had that brought success to this operation. So I was blessed with, like I said, you know, with some excellent people, some great projects, and money to do it. What a combination.
And I began in 1965, graduated right out of the University of Vermont, and that particular year, IBM was hiring, well, in about an 18-month period, I think they hired 1,500 people. So it was an exciting time. Of course, the technology, when I came on board in '65, we were making single reed switches and wire contact relays and Tross Mylar tapes, and we were populating these circuit boards. There was a product called SMS. And of course, then we launched into, I mean, the start of building 963 was to launch us into semiconductors in the latter part of the '60s. Well, of course, for me, I was a native, and it was a great opportunity for me, having grown up on a farm and educated right here in the county, to be able to get a job with someone like IBM. And I think because we were always leading edge in anything that we did, that it attracted people that wanted to do that sort of thing. And the work ethic, because I got to travel quite a bit, other IBM sites outside of the U.S., and you won't find a stronger group of people, more dedicated people there. And I think, you know, when you look around and you see who it is that you're working with, it's exciting. And of course, you know, you've got everything that Vermont has to offer as far as lifestyle, so you get to stay.
Remember in the 1970 when Terry Barr was a secretary, a 963 building, sitting there, and a deer came crashing right through the window and into the hall. We got a hold of security, and they went down and quieted the animal and had him removed and saved it. But what a scare.
After I'd been here about 6 months as a junior engineer, one of the very respected advisory engineers in my department took me aside, and he said, "Jean, you know, we really think you've got it on the ball. You're doing okay." And I said, "Oh, okay, yeah, you know, this is just such a fascinating program." He says, "No, but," he says, "you've got to find a different program to work on." And I went, "But 64K, state-of-the-art lithography, I mean, how much better does it get?" And he told me, "Oh, no, Jean. What you need to do is you need to work on a real program, because you're never going to be able to get the lithography down to around 2 microns and have it work reliably. And even if you do, defect density is going to kill you. And I love this part the best. And besides, you know, who in the world needs 64K? That's a niche server market. No one needs that much memory."
The Alpha line was it came on stream in 1978 was when the T2 of the products came. It was a System 38 that had the 64 kilobit. And give you an idea, 10 years earlier, we were just making 64-bit products. So in the first 10 years, the density increased 1,000-fold, and it went another 1,000-fold in the next 10 years, roughly. But it was an automated line. That's what the objective was. And I can remember when the line was set up, it was like a great big train, this model train. That's just what it reminded me of, with a control room, operational control room, MOC, and then all these wafers running around. And it was very difficult.
We were very, very concerned with contamination at that time. So it was felt that we had to keep wafers in a controlled environment 100% of the time. So the line was built with air track, which moved the wafers on a bed of air from tool to tool. As I said, we were ahead of our time. The logistics of that were very, very difficult to control. And in fact, when a tool would go down, it would really back up the entire line, even when we had duplicate tools.
The thing that everybody forgot about is that when you have an automated line, there are many transactions that need to happen. And we had a series of computers called System 7s at that point in time, and they couldn't keep up with the transactions. After the press conference, the engineers were on standby, and we went in and basically disabled the entire line for manual load. And over the period of the next 6 months, all of the automated air track went away. It's kind of nice to see that now we've gotten the compute power and the robotic power up to the point where the vision is actually running in 300 millimeter line, and to a certain extent in the 200 millimeter line here in Burlington.
Yeah. In the 80s, I was in the mask house. Okay. And that was where the shift took place from 1X masks on the Perkinomer 500s to making reticles for the steppers, which was a new technology that was coming in.
In the early day, masks and making a semiconductor was placed in contact with the semiconductor. Light shined through it, and you had your exposure. But often photoresist or parts of the mask, which was an emulsion mask, would stick on the wafer and contaminating the wafer, and you lose that lose that feature, and generally you lose that chip.
And as the technology demanded smaller and smaller images so that you were going below 1 micron, the ability to make masks at 1x that were both perfect and had the line sizes that were required just wasn't there. What you needed was the ability to make the reticle at a bigger dimension and then reduce it through the stepper lens and step it around on the mask.
When in the Alpha line we went to projection tools, so now the mask and the wafer were separated, and then a development from Fishkill of the pellicle, which allowed you to make a perfect mask, or I should say, if you made a perfect mask, you could preserve that perfection by putting a pellicle, which was a membrane about 1/4 inch away from the mask, and essentially seal it. So you had a sealed environment, and any particles that landed on the pellicle would not print because they were out of focus. And that was a tremendous leap forward and made a big difference in yield.
Of course, as the FET circuits came along, they were not as fast, but they used much less power. So there was a struggle within IBM as well as outside of IBM as to which technology was going to be preeminent. Was it going to be bipolar? Was it FET? Was it going to be silicon? Was it going to be germanium? You know, those were those kinds of struggles that were there. Different characteristics. But cost was on the side of FET as a mainstream product. And Burlington kind of won out there because we were the center of FET manufacturing excellence within IBM.
The changes since I came in IBM in 1978 have been phenomenal. I feel that we women engineers who came in at that time sort of laid down the path for the females that came later. And today it's a much better environment, much more understanding of a woman's situation, especially if she's married and has children. In my early career in IBM, having children was difficult, and especially when you were a manager, and you had to be there all the time. And so the attitude on the part of management, as well as the coworkers, has changed significantly.
C4 was here when I came in 1968. Wasn't that old. Controlled collapsed chip connection. Solder bump that then essentially melts.
One of the significant things about the C4 technology compared to other interconnection technologies at the time was the fact that it was so incredibly dense. All the other interconnection technologies at that time, certainly wire bonding was the primary one and was for many years, could only go around the outside of the chip, whereas the C4 technology could cover the entire surface of the semiconductor chip. And that gave IBM a tremendous amount of leverage in a couple of ways. There was not only the interconnection density, but because the C4 was a fairly significant chunk of metal, it gave a lot of good heat transfer characteristics to chips, certainly at that time when they were all bipolar and dissipated an enormous amount of heat. So there was a terrific advantage to C4 technology that other technologies did not have.
At that time, when I was working in the Marketing Support Center, and I was in the mid-'80s, there had never been a field failure on a C4 joint. Now that's pretty good.
One of the important contributions that IBM made in the 1980s was that of planarized back end of line. That technology was started in Yorktown and East Fishkill, was brought to fruition in Burlington, and became the standard of the industry. It allows you to make higher density circuits with many more levels of metal. By the way, IBM has not gotten much credit for this because it wasn't published. Rather than patent and publish papers, IBM decided to make it a trade secret.
Yeah, if you were to ask me, what were some of the things perhaps I feel the most, good about, or that I think when two fabs came together, I would tell you that was one of them. Because it was kind of old school. We had 973 and their products and their management chain, and we had 970 and their products and their management chain, and in the weekly reviews with the site executives, it was okay. 970 reported their progress, and 973 reported their progress, and
And there was such a lot of common elements that frankly, I'm kind of surprised it took us that long to figure it out. The transformation from 2 fabs to 1 really took place in a couple of stages, and in one stage we just started sharing a few tools, this thing we call the common back under the line.
We've always been very proud of our environmental compliance here at Burlington. In fact, we used to take great pride in the quality of the water that we put out to the river. I mean, because we sit on the Winooski River, we get our water from Lake Champlain, we use it, we treat it, we return it to the Winooski River, and then goes back into Lake Champlain. So for us, water quality is a very important aspect of our environmental compliance. We used to have a final holding pond because the treatment plant was only occupied or manned 8 hours a day, and then on the off shifts it ran an automatic. But before we discharged it to the river, we used to collect it in a final holding pond. And one of the operators down there used to keep fish in that particular tank. And you could go down there and see the fish kind of like swimming along the bottom and just kind of feeding on the algae and whatnot. We used to have bullhead in the final holding pond. On some hot days, occasionally, and this was never advocated by management, but some of the operators would go for a swim in the final holding pond. So